shows that the general solution of the differential equation given is given by. So we need just solve this differential equation, and we can see that we can separate variables, and it becomes dy over 2y squared minus 7y plus 3 is equal to 1 over 5 dx. 5 may be on the left hand side, it doesn't matter. Then we do integral, and question is how to take an integral on the left hand side. And idea is the next. We try to factorize the denominator, and if we can factorize it, then we do partial fractions. And if it cannot be factorized, it means that denominator can be represented as something squared plus a number, and that's why there are no roots, and that's why it cannot be factorized if it looks like squared plus a number, and then it's directly arctangent. The value of this integral is arctangent. So let's try to factorize, and you may try directly to consider 2y plus minus something, but I want to find roots and then just apply a formula, and roots are, so 2y squared minus 7y plus 3 is 0, discriminant is 49 minus 4 times 2 times 3, which is 25, so roots are minus b, so 7 plus minus root d plus minus 5 over 2a, so over 4, and for plus it's 3, for minus it's a half, then it becomes 2y squared minus 7y plus 3 is equal to, it's just the formula a is this coefficient in front of y squared, so 2 y minus the first root and y minus the second root, and it just becomes 2y minus 1 and multiplied by y minus 3. Then the left hand side can be represented as a over 2y minus 1 plus b y minus 3. Then we do again common denominator on the right hand side, and it becomes a y minus 3 plus b 2y minus 1, so it must be equal to 1, since denominators are equal, hence numerators also must be equal. Then we consider y to be 3 to get this to be 0, and we get, when y is 3, we get 1 is 0 and b multiplied by 5. Yes, so b is 1 over 5. Then when y is a half, to get this to be 0, we get 1 is a multiplied by negative 2.5 or negative 5 over 2 plus 0, so a is negative 2 over 5. Hence the left hand side becomes integral dy over, or actually it would be better to write a, so negative 2 over 5 and denominator is 2y minus 1, then b is plus 1 over 5 and divided by y minus 3 and dy, and let's actually you can see that we can multiply each term by 5, so it becomes 1 over 5 integral of dx, and you can see that we can multiply each term by 5, and actually we can integrate both sides. On the left hand side it's in general you may use the substitution u, but it looks like 1 over y, but it's over function, it's a function of ax plus b, and we can use the next rule that we use the same rule for integral as for 1 over y, keep the same argument, but 1 over a rises in front. A is it's a coefficient which is multiplied by y, so it becomes this negative 2, then 1 over a, so 1 over 2, and ln of the absolute value to y minus 1, plus here again it's 1 over y, but of ax plus b, but a is 1, so nothing rises in front, so it becomes just ln of the absolute value of y minus 3. ln of the absolute value, because integral 1 over x dx, it's ln of the absolute value of x plus a constant. And it becomes is equal to just x and plus some constant. Then we need a single logarithm, and you can see 2 cancels, and ln minus ln, it's what? It's ln of division, so it's ln of y minus 3 to y over to y minus 1, and in general it's absolute value and is equal to x plus c. Then we undo ln, and it becomes y minus 3 to y minus 1, absolute value is equal to what? E to the power of x plus c. It's because log 8 is 3, so 2 to the power 3 is 8, but ln is log to the base e, and the right hand side becomes e to the power of x and e to the power of c, constant to the power which is also constant, it's just another constant, so it looks like a multiplied by e to the power of x. And in general we know that if absolute value of something absolute value is equal to x when x is positive and negative x when x is negative. So if this is positive, it becomes just a times something, but if it's negative, it becomes negative a, but a or negative a is some constant to be found, and we can write just y minus 3 to y minus 1 is some constant e to the power of x, and this constant will take into account this value to be positive or to be negative, so it doesn't matter this positive or negative, it is already included into this unknown constant, it's already taken into account by this constant, and it's actually the general solution, and we need it to be solved for y. So just solve for y. It becomes y minus 3 is 2a e to the power of x y minus a e to the power of x. Minus y. And this to the left or to the right, so it becomes y 2a e to the power of x minus 1 is equal to a e x minus 3. Then y is a e x minus 3 to a e x minus 1. As required. And that's all for this question.